So hello guys, welcome back to my YouTube channel. So in this video, I'm going to create a project which is personal protective equipment. So in this project, we are detecting boots, ear protection, glasses, gloves, helmet, mask, person and vest. 8 things we are detecting here in this project using YOLOv11 model, and it is a computer vision project. So for that we are following some steps using in this project. First of all, we find a data set, and then we are training the model, which is YOLOv11 on that particular data set. After that, we are predicting these 8 things on the particular images and videos. So for that, let's get started. So first of all, start with the Roboflow website, which is gives you labeled data. It reduce your time, and also it will very helpful for annotating and all, because it is a very lengthy process to follow these things. So here it is a Roboflow website. So in project section, these are the projects which on that I am worked on that. And here the workflow section, you just set the workflow your project and all. Monitoring is a paid version. Deployments, it is also a paid. Going to this one, explore section. Here you are finding the lot of data set which is labeled data set, and easily you find your whatever projects you are like building on that and all. So I'm just going with the personal protective equipment, which is this one, safety. Click over here, this one project. I may give you a link for that particular data set. Click over here, versions, download dataset over here. In this dataset, you can upload more images and you just annotate them, which is the fully functional process of the computer vision projects. Here's the dataset section. Here we are using the 600 images in our dataset, and you can clearly see that the labels or particular images, you just edit it and fine tune these things, and you just do it manual also. So just click over here, versions. Okay, so now you just click over here, download dataset. In this you are finding the format, like which of the models you are using this dataset. It is give you a compatible with these models. Okay, so easily click over here like YOLOv11. So click over here. After that, you see that the download options, first is zip. In this, here you can download all the images and annotations and classes, whole data set, which is GBs of the data. It takes your spaces also. So I'm not going with that. I'm going with this one, show download code. Show download code. In this, click over continue. It gives you a code. Just copy it and run it your notebook. I just copied here. Okay. So now it is an image data set. So for that, we are not going with the VS Code because I have CPU. So I'm going with GPU. So open your Colab, Google Colab notebook, open your drive, and just right click over here, more, connect more apps, search here, COLAB, Collaboratory, Google Colab, install it, continue, give some permissions, sign in with and all, done. Okay, just cross it. Now right click on your drive, go to the more section. Here Google Collaboratory is visible. Now click over here. Okay, so your Google Collaboratory is open. So here in this notebook, just connect it with the GPU. First of all, it is on CPU. Change runtime type. It is on, make it on T4 GPU. Okay, save. It is connecting here. Okay, so now it is connecting. Our directory is clean. So first of all, for that YOLO you have to install the libraries like ultralytics. So let's begin with pip install ultralytics. It takes 1.5 minutes to installing ultralytics. Okay, so let's wait. Okay, so let's check dependencies are properly installed or not. So just import ultralytics here. Ultralytics dot checks, run it. We are using a GPU, so CUDA version is visible here. Okay, Ultralytics Python is 3.11.13. Torch is this, CUDA version is this. So we are using GPU. So for that, CUDA version is visible here. Okay, so let's import required modules for YOLOv11 and visualizations and all. So from Ultralytics, import YOLO YOLO in caps. We are showing this images on Colab notebook. So for that, one library is ipython dot display import image I capital, run it. Okay, so now paste the code which is YOLO's library for downloading the data set and all. So here this one is the code we copied from the Roboflow website. So just run it, and you see in our directory there is no folder and any data set and all. So just run it for downloading our dataset in our directory here in this folder. Okay, restart session. Okay, we have to run it again. Safety one. See here, the safety one is visible here, this folder, which is dataset folder. Okay, so okay, our data is successfully here downloaded. So now see our in our directory what are the files are here in our directory. So dataset dot location, just run it. Okay, in context we have safety one folder. Okay, so here just import our model for model training. Just write down here for the YOLO task equals detect mode equals to train data. Okay, now which location? This one. Give it in curly brackets. Okay, slash data dot YAML file. And one more important thing, we have to update the locations in our YAML file. Okay, data.yml. Our model name is YOLO11 and .pt. We are using this one. Epoch size is 100. We are training on 100 epochs. And image size img as z equals to 640. Okay, so for that, first of all, click over this download data.yml, give them proper path, images, test images, copy path, test this one. Okay, save it. The star mark is removed, so this is saved. Just close it. Okay, so now our YOLO task detect spelling detect mode equals to train data. location is this, and data.yml. Our model name is YOLO11 and .pt. Epochs are 100. Image size is 640. And these are YOLO. Search here YOLO models. This website Ultralytics. Okay, so here you clearly see that the models and all YOLO 11. Okay, so here a lot of the models are here: YOLO 11, SEG, POS, OBS, CLS. So in this we are using YOLO 11 and .pt. Here it is. For that, it's the purpose is task is detection. For detection purpose, we have YOLO 11 these models. Okay, in instance segmentation for this, we using a YOLO 11 SEG, pose and key points, position estimation points, skeleton points, and all. Orientation detection, classification. For that, we have lot of models here. For 11 and the size is image size is 640. We are here put it here. The image size 640. It's a standard. Okay, and here it is. You can see the params, speed, CPU speed, MAP values, FLOPs, and these are the our models here, YOLO 11. And so here just run this one file, which is data.yml. Now run it. It is trained, this model is trained on these data, personal protective equipment images. So here we give the 100 epochs, so it takes some time. Okay, so 99 epochs are completed. Okay, so last one 100. It takes almost 15 minutes. Wow. Okay. Okay, so it takes almost 15, more than 15 minutes, 15 minutes and some seconds. So here clearly see that the in our folder runs folder is created. In this folder, detect the all the training of the models, the bounding boxes images and predicted images are present in this folder. So runs detect train. These are our models. Best.pt is our model and last.pt is our model. Okay, so here I just show you a full name of these files. Okay, so here just evaluate our model, see the performance, what are the performance of our model and all. So first is confusion matrix. This one, this is a PNG image. We are showing the image over here, confusion matrix image, IMG image. Here R, copy the confusion matrix path here, copy path, just paste it over here. Okay, comma, give the width of the image around 800. Yes, see the confusion matrix. If you are a technical guy, machine learning models, you know, then you very familiar with this confusion matrix. Boots, ear protection, glasses, gloves, helmet, mask, person, vest, and background. These are the score of these metrics. Okay, so let's see another one, which is a label images. Okay, image, wait, label.jpg, labels.jpg. Okay, copy path. Okay, run this. Give the width of this image, which is around 600, little bit. Okay, so here instance is this. Boots are highly detected in our dataset, and ear protection is mm, lesser. Last one. Glasses second last. Mask is third last. Gloves. Helmet is also highly detected in our project. Persons vest. Okay, so these are the detection like labels, highly labeled in our data set. The model is detected. Okay, so see the last image. I capital image read just results.cs dot png. Copy paste, paste, give the width 600. I think okay, little bit more 900. Okay, so here training box losses reduces epoch size, which is 15 epochs. The loss is around zero point 0.7. It is also reduced, and here the smooth is like this one, and 50 epochs, 100 epochs. The training loss is also decreases. Matrix precision recall is increases, and the each epochs, I think 50 after 50 epochs the precision is constant and recall is also constant. Okay, so next is just display the predicted results. Okay, so here in this folder weights, all these are the batches, like images batches, images 4 by 4. Yes, this is the 4 by 4 image. Here you see that the 0, 1, 4, 6. Okay, so these are the batch images. I'll show you in full display. Move on to the next. Go with the next point, which is display the results, prediction result. YOLOv11 saves the predicted images in result folder. So okay, so I copied this code over here. YOLO task detection model is our best.pt is our model. Run this. It creates one more folder here. Okay, so this is the summary of this our model. So now save this these images into our directory. Okay, then next is find this one globe. Okay, so after that run this inference to put the image in our directory. Okay, so this is our model bash.pt. confidence is confidence is 2.5 and 0.jpg. Run this. You see here our this model evaluation data.yml, this prediction 1, the all the images here, and prediction 2, which is this image 0.jpg. This one we saved this image, save is equals to true. We save this image in our directory. Okay, so let's see this image. So here we just put this code. Okay, so person helmet. So this is the on the image. Let's see on the video. Okay, so I have one video. This one playback. Just drag and drop here. Upload it in our directory. Okay, here it is. So let's see this image. See this video. I have the code for this one. YOLO task detection model, predicted model, this best.pt. Source is our this one video. Confidence is equals to 2.25. These are all are the boundary boxes above the 2.5. 40, 66, 96, 95, 94, 78, 87, like that. So here video is uploaded. Okay, run this command and the video is saved in this predicted 3. Image is saved video playback.avi. Okay, let's show in our notebook. So for that You have to paste this. You have to run this code for showing the video. See this video. All the vest, helmet, boots, and person. Red one is the person, and all are the confidence interval is 2.5. Okay, so I run this model on images and also the video. Okay, so now build a web on a Streamlit. So for this you have to download this model and the data. You can't directly download this data from here. There is no option to direct download this run folder. For that you have to run this code, which is I provided you. I give you the whole code and hold the notebook in the description and medium. There is no module Streamlit. Okay, first of all we have to install the Streamlit. Okay, now run this. Sometimes it work and sometimes not working for the zip the folder. Okay, so it can't generate the zip. Okay, so let's try with another one, which is this one. Here we are zipping the run folder because we have the model in this run folder. Runs detect train waits here. Best.pt is our model. So just run this. Okay. Run.zip file. Yes, here it is. It create the zip folder and downloading it also running here. Automatically download the runs.zip file in your download section. Okay, here it is runs.zip is downloaded. Okay, I want to download this dataset also, safety one. So for that, I run this one code. It create a zip file where run detect. Okay, run detect safety 0, run 0 safety.0. Here, just download it here. Now you have the model batch.pt, your dataset, your run folder, and your dataset folder. All the directories you are using here available in your zip. Okay, so this is the complete step-by-step process to detect using the YOLO model for the your custom data. You just create this your own data like any other things, your own project. So I just update this IPYNB file, notebook file, in a very attractive manner and all.
10 years later.
Okay, so here I update this notebook, personal protective equipment project using YOLO model. I generate this image using the Leonardo.ai. So something is missing in this, like YOLOv11. Okay. So personal protective equipment YOLOv11. This notebook demonstrated how to detect personal protective equipment such as boots, ear protection, glasses, gloves, helmet, mask, person vest using the YOLOv11 object detection model. We are installing this Ultralytics library first of all, step 1, and next import some libraries. Okay, check the environment like successfully dependencies are properly installed or not. Then import our libraries YOLO from Ultralytics and image from ipynb.display. Then download the PPE dataset. We are copied the dataset from the Roboflow. So paste it over here. This one, easy process. Just run this one, and after that just check the location and training our model. Before the training, we just update the changes in the YML file for train.image, you know, and test.image and train test and val. For these three files, we are updating the file path for these three files. And then model training. Then we are taking these three images like confusion matrix, labels, results with the width size also to adjust the width and clearly visible. Then we see the our model is correctly predicted or not. So here this one is the best.pt data.yaml. So I just unzip runs here, detect one. Here this one is one by one images are downloaded, and you clearly see that one by one images with the boundary boxes what the model predicted. Okay, so this one code shows you prediction one folder, and after that we are save the images more than confidence interval is 0.25. Okay, that images and that the boundary boxes. Okay, then image prediction results here. So YOLOv11 save after running the inferences. YOLOv11 save the prediction images and boundary boxes on the detect prediction. This is the second prediction folder. So for that globe library we are using here, and then inferences I uploaded on the 0.jpg file. So here it is the third one. Where is the zip? Here. This predicted to 0.jpg. It shows you complete boundary boxes and all. This is the custom images I provided on the Colab, and we save these images, save the images and the show this image using this code. And after that, this one is for image. Then we are trying for the video playback.avi format. Okay, confidence interval is 2.25. After that, compress the YOLOv11.avi to MP4 image, MP4 video. Okay. After that, we are zipping the file using the Streamlit, and it is not working. But after that, we are using this for run.zip file, this code, and after that, we are downloading our dataset. This is the zip.runs.zip is a predicted models file folder, and then this is one is the for our dataset and all. Okay, so here you clearly see that in our zip file, predictions and all, training and validation. Okay, and here safety one, train test validation data.yaml, and all the train the images with the labels directly from Roboflow. We can directly download from the Roboflow, but we are using this code for the downloading this. Okay, so that's all about this personal protective equipment, the code and all, the internal process and all. Now we are working on the Streamlit Web App UI. We are creating the UI on Streamlit and like drag and drop and all. Just you like see in this video here. This one. Okay, files here. Oh, where? Personal protective equipment. This one videos. Just for image and video, we are choosing here two options. Then drag and drop and just cancel this option and all. And after that, it will shows you all the boundary boxes. Also give something one more addition feature, which is confidence interval over here. One is the feature is more. So that's all from my side and this project. The next step is creating on the Streamlit this web. Okay, so thanks for watching this video and see you in the next video part 2. Bye bye.